How's it going, everybody? This is my first video that I'm posting to the geometry course, and we're going to find out how to find the area of this polygon, which happens to be a triangle. So here we go. First thing, if I'm looking at this triangle here, I see that this line right here, BA, is a base, and since, let's zoom out a little bit, if I can count the boxes here, I got 3 this way and 4 that way. I already know that's a 3, 4, 5 right triangle, so I'm going to automatically say that side is 5. The other side, which if we look at it, it's right here. I'm going to go to a different color here. Let's try yellow. This side, this side right here, a little harder to determine what the length of that is. So I'm going to make a bigger right triangle. Go back to red, and I'm going to count over. I got 1, 2, 3, 4, and I go 8 more this way. So that's 12, and then I go down. That's a full 10 plus 6 more, so that's 16. So it looks to me, hold on one second. It looks to me like we have side AB equal to 5. And now we're going to look at side BC, but we don't know what that is yet. But if I consider it like the Pythagorean theorem formula, I could say that this is c squared equals a squared plus b squared. So I can square this if I want to find out that length. And I already found the 10 of the 12 and the 16, so we can put those right here, 12 and 16, which we would then need to square them and add them. So now I'm going to drop this down here, and 12 squared is 144, 16 squared is 256. I'm going to add those together, and that's still our BC length squared. So BC squared comes out to be 400 total if you're squaring it. So now if we took the square root of both sides like this, our length of BC would be 20. So let's take a look at what we have right now. We have the base and the height of a triangle, and we know the area formula, which is way up here, is base times height divided by 2. So it looks like AB is our base. AB is our base. Let me just draw that. AB down here is our base. That's right here, 5. And BC looks like the height of our triangle. BC is 20. So if we needed to find our area, which is base times height divided by 2, in this case it would be 5 times 20 divided by 2, which then just comes out to be 50 units squared. And that's it. That's your full area for this triangle. Done. Okay, this is the second problem of the night. It is on the last page of your packet. I'm going to work out number 1 for you guys so you could see how you can handle this if you didn't have a coordinate grid to work with. So the first thing I look out for is if any of the numbers match in the coordinates that you're dealing with. For example, on B and C, the y value is the same. It's a -2. To me, that means that if I was to graph it on the coordinate plane, the y value wouldn't change. So it's going to be a horizontal line like that. And the good thing about that is all I really have to worry about is the distance between B and C in just the x direction. Because if you just look at the x direction, it's going from a -6 to a -1. So if I want to subtract it either way, you'll see that if I do -6 minus -1, these are going to turn into positives, and then you're left with -5. Or if I go the other way, if I do -1 minus -6, and these turn into positives again, I end up with +5. So considering the fact that they both come out to be either positive or negative, it only depends on which direction you're going, so we just take the absolute value, and that is a length of 5 units. Without having to do really much math there, you can see that there's a distance between those 2 points of B and C of 5 units. So I can just write down that BC equals 5, and I can get rid of the other stuff that I already wrote, because now you understand why BC would be 5. This is my first time messing around with it, and I got this little thing here that I don't know if you could see in the video, but I can't seem to get rid of it. Plus, I don't know how to move this BC equals 5. I wanted to move it somewhere else, but it doesn't work, and I can't seem to erase it either, which is kind of annoying, but I'm getting used to this program. Oh, it's called Explain Everything, and I might have you guys use it at some point in the future, but not tonight. So now I notice that AB also, if you look at those, they have something that's in common, the -6. So that means that if you were to graph it, the x values would be the same, and you would get a line that's vertical. And it would go from a -10 to a -2. So we can think about that. So now, if we have positive 10 minus -2, these two would turn into positives again, and you'd be left with 12. Or going the other way, you could do -2 minus 10, and that comes out to be -12. And like I told you before, if you consider the fact that it really doesn't matter, whether you're going left or right, or in this case up or down, it would just still be the absolute value of 12. And that would mean that the length of AB would be 12. No matter what, AB is 12. So now let's review a little bit here. Our AB was a vertical line, and our BC was a horizontal line on the coordinate plane. Wouldn't you say that those two would be 90 degrees from each other? And if we look at the area formula, which is up in the right hand corner, it's the base times the height divided by 2. So one of these we can consider to be the base. I'll do AB. Actually, no, let's do BC because you guys are used to seeing it horizontal. And the other one we'll call the height. Finding the area would just be putting those two together. So that would be the base of 12, a height of, oh, I messed that up. I'm going back to that. We have an area, which is the base of 5, a height of 12, divide that by 2, and we end up with 30. Now, even though we don't need it, I'm going to show you how we can use the distance formula to find the distance between AC, just so when you're doing your work tonight, you can know how to do that. Okay, so from A to C, I'm finding the distance of AC using the distance formula, which in this case, let's go with x2, so -1 minus -6 squared plus -2 minus 10 squared, and that's a big radical symbol. So this comes out to be 5 squared plus -12 squared, still taking the big square root of that, it's 25, plus 144, big square root. So now we have the AC length to be 169, which is the square root again, and then finally that comes out to be 13. So we did not need that, but I figured I'd do it just to give you one demonstration of the distance formula, just in case you need it for the rest of your work. Okay. One last thing, I'm about to show you something interesting, and that'll be important for you later on. That is something interesting. Good night.